Check, check. Testing. All right, let's do this, guys. What's up, everyone? Welcome back to Better Biomed. Today is one of those days where I'm just going through and I'm cleaning up my desk and I got some old projects here and I'm like, you know something? I need a little bit of a break. And in doing so, I sit back and I do some of these do-it-yourself electronics projects because they give me that moment of respite that I kind of need. And it's a mundane task putting these things together, but it's fun. And there's a lot of attention to detail that goes into these little do-it-yourself solder kits. I figured, let's just go ahead and assemble this one. I'll do it on a live stream. It's always fun. And if you guys have any questions or anything, I would be more than happy to help you out with that. So you see me looking around my screen here. That is going to be me. I have multiple monitors up here. I'm going to do a tour of my studio sometime soon. I have been putting up brand new lights. So I've got studio lights up now. I've got backlit for my green screen over here. It's been a lot of work. So if I appear like I'm maybe a little tired and everything, it's because my phone has been just absolutely blowing up for days, and that's a lot of people to coordinate and stuff, and it just kind of wears on you a little bit. So that's why I do projects like this. Keeps me focused and it keeps me rested, and I figured maybe take you guys along for the ride. So let's go ahead and let's do this. So this project here, let's see. All right, here we go. And a new microscope. How about that? All right, guys. So this way here, you guys can actually see how I do this kind of stuff right up and close and personal. All right. So I do these electronic kits all the time. I think they're the best. Of course, this kit right here is going to come with Chinese instructions. But what it does tell me is a rough circuit diagram right here. And from that, if I get lost in the chaos, I can refer back to this guy, because you can see one component directly connects to another one and you can see the relationship. With that, technically, I could probably assemble this without even having silk screening right here on the board. This is actually pretty good. This is not good. So anyway, we're going to do this one together. This is a digital time clock, I believe. It's a digital time clock, folks, and I look forward to it. Okay, so this one right here, you can see I've got a IC stage already mounted in, and I did that mainly to test out the microscope. I'll admit, it's a toy. You got to play with the toys. So let's kick it back over to the microscope so you guys can see up close what I got going on. I do have a chat window right here, so I can see you guys as you chat, so thankfully. And Katrin says, what will it do when it's finished? This one here should be a digital clock. I could be wrong. I could be wrong, but it should be a digital clock. All right. So let's go ahead and let's put the Chinese instructions off to the side and let's figure this one out together. Now, one of the things I think is a pretty healthy thing to do, almost with like any jigsaw puzzle, is you kind of lay your components out. You can see already that some of my components are a little bit damaged. All right, so carefully straighten out some of these legs. All right, this is going to happen all the time. It's just nature of the beast. So what we're going to do is we're going to straighten the legs out with a set of pliers, and it's looking pretty good. So I'm going to lay those off to the side so they won't get damaged. Once you inspect all your components, got some buttons that we're going to be soldering in. You see that? Tiny little guys. I have a power port, and I've got a whole series of resistors and low capacitors. I've got a transistor right here, and I've got a clocking crystal right there. So since it is a clock, it needs something to keep time, right? and that is going to be through the clocking crystal. All right, hold on. Okay, all right, guys, sorry about that. Business does not stop just because I'm tired, right? I'm working on 3 rather large projects, which could be game changers. So it takes a lot of effort. So what I'm going to do first is mount the largest components, and you can see here that I've got this guy here mounted. Now there is some indexing that we have to take notice of. Let's see, where's my pointy stick? All right, let's just use this guy. This guy should work. Okay, so you'll see a little indent over here on the silk screening, and that tells you the direction that this little chip stage is got to be mounted. It's got a little divot down here. It should match the divot that is on the silk screening. Next, I'm going to go to a large component called the segmented display. All right, now these ones here are very easy to get damaged, so you got to check to make sure all the legs are nice and linear like that. And what we're going to do is we're going to mount that bad boy right here. Now you can see that there's some numbers on the bottom. I'm going to go ahead and stage this guy so that those numbers are also going to be on the bottom. Okay, just like that. It fits in. Notice how I've got this vise sitting here, but I'm going to be sliding it in and out. So when you put a component into your PCB, always bend the legs just a little bit, okay? Just like that, okay? By bending the legs, that component stays in there. You see that? So just take 1 or 2 legs, bend them out. It also gives you free open access, all right? That's going to be very important while you're soldering to make sure you got open access. Now, I've already cleaned, well, it was at one time cleaned with rubbing alcohol, but this board, you can see how it got dirty from the flux. So, the solder traces are all clean. I just took this one out of the bag. And because of that, we should be good to go to just solder this guy up, all right? Should be. Now, if we start to see solder sticking between the posts, then we're going to go ahead and we're going to use some flux. I've got a series of them over here. And let's go ahead and just get that started. I've got, let's try this one. I've got a whole bunch of different 60-40 solders over here. Yes, folks, I do like leaded solder. I do. Okay, so here we go. Always make sure that your soldering iron tip is nice and clean when you get started. And we're just going to start feeding. So I'm going to be placing my soldering iron tip, which you can see that it's the shaved off oval. I absolutely love this one here because it holds solder so well and it maintains its heat, which is going to be very important. So what I do is I place my soldering iron tip down at the base of the post and I feed the solder in from the opposite side. So what you're doing is you're heating up the pad and the post, the leg of the component. You are not heating up the solder, okay? That is going to happen, but you're not heating up the solder. You're heating up the post and the pad, and then it will bond with the base metal, and it's going to happen really quickly. My soldering iron is actually staged pretty hot. I have it at 350 degrees C. I dig it at that temperature because it allows me to get a lot of stuff done really quickly. Now, normally I do have some larger vices that I use over here on this, but because of the field of view of this camera, I'm going to elect to do this little vise. It works. You can see this can happen really quickly. All right. So once we get them all soldered, then we're going to examine them to make sure that we have good solder joints. And look at that. And this microscope really makes it stick out, huh? Those are excellent solder joints. And what you're going to need is a set of flush cutters. These guys right here. They're called flush cutters. They work fantastically. And I always shave off the legs of my components. Actually, you know something? I know better. There we go. Sometimes when you cut these legs, they just explode. There we go. There we go. I can always clean this up later. All right. So we have our two largest components soldered in place. You can see that this will start going pretty quickly. The next thing we're going to do is we're going to go and we're going to do the buzzer. The buzzer, where's the bad boy? Right here. So you can see these are polarized components. That leg right there is the plus. So we're going to match that up right here. Plus, minus. Here we go. And we're going to make sure that it's seated down as far as possible, and we're going to bend out the legs just like I did on the last one, and that will hold your component. Okay, let's do it. There we go. All right. You can see how the soldering iron tip kind of wicks some of that solder up, and it keeps a pool of it right here on the bottom. So I'll be reaching off camera to my solder tip cleaner right here. Got to make sure it's nice and clean. Okay, we've got the three largest components. Now probably one of the most important components is going to be this guy, right? So this guy right here is a power port. We want to make sure that the axis is facing the outside, like so. There we are. And these ones are going to be very difficult to bend the posts. And in fact, I would recommend not bending the post. So what we're going to do is kind of brace it. Come on. And I'm going to tack it. This is the balancing act that is soldering sometimes. So make sure it's all the way down. Ah-ya. Okay, there we go. I want to make sure that that is as close to the board as possible. There we go. Once one side's tacked down, then we can hold the board like a normal one. Wow, that was a little dramatic. Okay, let's do it. Perfect. Now you can see my solder kind of bulged up on that guy right there. I'm going to clean off my soldering iron tip, and you will see it wicks a little bit of it away. There we go. That's how easy it is. That's why I dig these oval soldering tips. They just make it so much easier to control the amount of solder. Okay. All right, so our next component, let's try this crystal. All right. Now the crystal should not be polarized, but I'm going to match up the frequency direction the same. So it says 12 megahertz there. See, I'm going to put it right here. Boop. There it is. Same thing. Spread the legs of the component so it stays. There it is. Too easy. Clip it off. Now, I can't tell you, as you do larger and larger projects, you got to be careful when you clip off these little pieces right here, because they will end up in your arms and stuff. So try and find a good collection point. Don't just leave them all over your desktop. These little guys will get into your skin, and it sucks. All right, there we go. Now I'm pretty confident, and I want to preserve my IC chip. So this chip right here, I'm going to place it in the holder right now because otherwise it's going to get damaged sitting here on my desktop. All right. So I've got a little divot down here, and that's going to correspond with pin 1, and that's also corresponding with the silk screening. Let's go ahead and pop this guy back up there. You just got to make sure to match up all the legs, make sure they're not bent. And sometimes with these chips, you got to kind of press them in one direction and then allow the legs to find a spot. It's not always easy, especially if the chip's been damaged previously. This one here, I had to bend it by pushing it that way, line up all the legs on that side, and then I came back the opposite side and pressed it in. Sometimes it's easy, sometimes it's really difficult. So this one, not so bad. All right, so keeping up with the theme, largest components to smallest, I have a resistor network right here that we are going to be installing. And to help me do some of these, I've got these spring-loaded tweezers. Right? So these are really good because you can hold components. See that? It's not taking effort for me to hold those components. So I just stick it up like this, place it in. Now notice how it's got a dot right here, and see how it's got a designated pin over here. So we are going to make sure that we put it in the correct orientation. And I can see right now that that is going to be a challenge because I got those other components in. Lovely. There it is. Okay. So took me a little bit because I had to line up all those legs. So that's it right there, up and inside. And for this guy, what I'm going to do is use my tweezers that you just seen. There we go. I'm going to use my tweezers to hold it in. I'm going to invert it, just like so, and I'm going to tack in some of those legs, all right? Seems unconventional, I know. I'm just checking it right now to make sure that it's all lined up, every single leg is in. Let's tack in a couple of these legs so that I can remove my tweezers. Right, so that is strong enough to hold it. Remove my tweezers. Let's place it back in the vise. There we go. I hope you guys can see this pretty clearly. I really dig this microscope. This is the Joya Lens microscope, and it's way above my head. It's like 2.5 feet up, which is so cool to have this kind of luxury of field of view. All right. Let's attack it from this side. If I don't like the way a joint looks, I'm going to go back and I'm going to touch it again. And what we're looking for is that perfect little triangle, that Hershey's Kiss look. That tells me that I got the correct amount of solder on and that it made a pretty good bond with the base metal. Nice. I'm just cleaning up some of these other solder joints that are near it. There we go. Nice. All right. So we got those components in. I have some buttons, some capacitors. Let's do the buttons next, folks. And let's see, it looks like the two buttons go down here at the bottom. Now it's going to be really important for these to get put in the correct orientation, because if we don't, then we are going to be putting them 90 degrees out. And there's not too many indicators on these buttons what's what. Okay. That is not fitting in too well. Let's go ahead and move him out of the way. So what I'm trying to do is get these bent legs to line up correctly. There it is. Without bending. You can see how that one right there wanted to bend. And now we play the game. So I got those two on that side in. And what I'm going to do is move these ones a little bit. So you cannot force these. They got to be nice and gentle. There we go. So that one took a little bit of work. You can see how they're going through the PCB. Let's go ahead and tack it in. It's actually held in by friction pretty well. So these ones are kind of easy. Okay. And this front one right here is not complete. There it is. All right. So there's no components to clip on the buttons. Just check to make sure that you didn't overheat it. Make sure it's still clickety clacks. We'll press on to the next one. Ooh, okay. Next, so we got a sister button that's going to sit right next to it. You can see how the legs are kind of bent out. See that? That's the challenge, is these components often get damaged. Okay. All right. Not so bad. So you can see I'm just taking my time. Just kind of making sure that they all go in the hole perfectly. And you want them to sit flush to the PCB. All right, let's tack that guy down. It is a fairly simple IC there, Chris. This one here is just a timer circuit because this is just a digital clock. So this one here should be pretty easy. All right. So I haven't even looked to see what these buttons are for. Probably to set the time, to select, and then for each division. Now here's something interesting. The last button went perfectly well, and this one here is not, okay? And what I'm saying is, once you start doing a lot of these, you'll notice like sometimes it feels like the metal's dirty. The solder will not adhere. You can see it. It's bubbling up on these two. It's forming round droplets. And this one here is not even, it's not even really creating that smooth Hershey's Kiss that we like to look at. So this is a perfect instance where we are going to use some flux, all right? And that's because it's a little bit dirty, and we're going to give it a little bit of love. Let's see. I've got a few flux brushes floating around, but I'll just use this guy. So what flux is going to do is it's an acid that cleans the surface of the metals, and it allows the natural fluidness of molten solder to take its course. It creates a pretty good bond between both the metals. Without it, you're relying on it being a clean surface, and you're relying on the solder having enough flux in its core, and that is not always the case. All right. And now the solder is behaving pretty properly. There it is. Okay, take a look at that one. All right, so you guys are probably noticing this guy right here. It's still not looking right. The metal is dirty. So I'm going to use some of my isopropyl alcohol. We're going to go ahead and clean it a little bit. And yes, my desk is now a fire hazard. Okay. And let's also step it up. I really dig this larger diameter flux core. It's got more flux in the core. And because I have a hot iron, it allows me to go really fast. Okay, let's see. Good. Good. Man, those two right there were a challenge. The metal on the leg for the button was dirty, very dirty. There we go. Beauty. Okay. And now I absolutely reek of alcohol. Oh well, we'll be all right. So let's see. I've got some large capacitors. I have a transistor to install. Let's go ahead and do the transistor. So they have 3 legs. And notice how the silk screening right here for Q1, it also has 3 legs. So what we got to do is we got to bend it to fit that function. Okay, you can see I kind of created a little triangle right there. And that is what we're going to fit in there. Come on. There it is. Okay, you can see it. I sat it down pretty close to the PCB. Transistors, don't push them all the way down. You're going to get nothing but problems. But I got it down pretty far. All right, let's tack this guy down. And I think that was all 3 of them. Good. Perfect. Man, My flush cutters have had better days. I need to get me another set. All right. Okay. Let's take an inspection. It's looking pretty good. You can see some of the corrosion on the PCB a little bit. We're going to clean all that off with that alcohol. All right. Let's start doing some caps. Now this board is just a little bit off. You see me goofing around with it. It's because in one direction it's a couple millimeters smaller than the other. So this way here it slides into these tracks, and the other way it doesn't. It's kind of aggravating. Okay, right there. So I've got some large electrolytic capacitors. These guys right here. They are indicated for their polarity, and same down here on the PCB. So their ratings are going to be on the side. So this one here is flying around my desk. Okay, so this is 16 volt 100 UF, and the 100 UF is right here. The white side we're going to line up with the white stripe, like so. These you can get right down close to the PCB. Come on. And normally when I'm doing these kind of boards, I will put 3 or 4 components in and then solder it up. But today I'm just doing it one by one. One by one. Right. Okay. It's looking good. Next we're going to do the only other electrolytic I can see. It's going to be this guy right here. That's what, a 10 UF microfarad. So let's go ahead and line it up. Positive, positive, negative, negative. So here you can see the solder bulged up right there on that side. Again, take the hot iron, touch it, see how it sticks to the heat source. So it flows from the component to the heat source. That's very useful, extremely useful when you're trying to moderate the amount of solder. Okay. I'm gonna have to move this microscope over there eventually because this is not my soldering bench. This is just where I'm in front of the cameras. And over there I have everything set up nice and beautifully. So, sorry folks, I'm not keeping up on the chat. What's the downside of always using rosin core solder? You know, honestly, there is not much of a downside. So the important thing, there's a lot of discretion over like yanking it, melting it. I usually melt my solder. You'll see me, I'll take my iron now, melt it. Some people are like, oh, you got to clip your solder. No, I really don't care. I go through solder kind of quickly. You can see that there's a big diameter difference, okay? And I like using the larger core, and that's because it's got more flux, and because, in my opinion, I don't go through it as fast, and that's really good. It gives me a lot of control. I can bend it like this. It'll stay in the direction that you want it to go. And I can go around components and just burn a little bit, like tap, 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 tap. So I dig this diameter right here. Let's see, what is that? So that's 1.2 millimeter. It has 60/40. And that's my favorite. It's clearly my favorite. But when you're doing smaller connectors and stuff, you got to switch it up. So that's why I have some of these other ones. It's just a preference. Let's see, didn't realize there's a need for extra flux if you're using rods and cord. Yeah, absolutely. As you guys seen, it wasn't sticking to the component legs. The legs were dirty, so you use a little bit of extra heat and you use that flux. And that flux, when you liquefy it, that acid gets in there and it cleans the surface of the metal. As you can see, I was using a large core flux solder. I used the smaller one. It just wasn't sticking. Then I applied the flux and I heated that little bad boy up, and I also cleaned it with some alcohol. And you can see that it adhered, and now my buttons look beautiful right here. See that? They weren't sticking. So it's not even really sticking. I shouldn't be saying that. It's you're bonding two metals together, all right? And it takes a lot of heat to do that in clean surfaces. Okay, so I have one resistor right there that's going to be an absolute pain in the butt. So let's see, I got some 4.7s, so these must be the 4.7s because I have 1, 2, 3, 4. Let's see, yeah, 1, 2. Let's count them out together, guys. I got a 4.7 there, so that's 1, 2, 3, 4. And I got a couple small ones. This one right here, some diodes. Huh. They gave me 5 resistors. Maybe they just gave me an extra. Anyway, you can see that we got some diodes going right here and right here. Okay, they're both the same ratings. That's going to be these two. Just note that the diodes are indicated for polarity. That's the white stripe, and it should match up with the white stripe on your PCB. So I'm going to bend those ones over. Here we go. Sink it down. Let's do it for this one. I'll show you how we can assemble these pretty quickly. I've been going slow, one component at a time, because that way there, you guys can see what I'm doing. If you have to ask questions, you can ask questions, but this is how I normally do it. Put several of them in, and then just hit it. It's just go for it. So these are 4.7s. Resistors are omnidirectional. You can put them in however you want. And these ones are extremely soft legs. There we go. Right. Too easy, folks. This is why this is so relaxing, guys. What decides the diameter of cord you use? I've always gone somewhere in the middle just to be safe. What do you mean by cord? Do you mean like power cord? Is that what you're referencing? I'm kind of curious about that, Brennan. Here we go. Right, so all I'm doing is spreading them out on the bottom side. Oh, there's the other one. Okay, I see. All right, we got all the resistors accounted for. Gotta flip it up in order to see it. These darn things are so tiny. Okay, here is where these come in pretty handy. Right. Last one, folks. I do have some little patty capacitors over here to put in, but those are easy. And the other one's right here. Right. So I got this little porcupine matrix that you see on the bottom, and you're going to see how fast I can solder those up. It's going to happen real quick from here. So when you're dealing with these Chinese kits, there are some American kits, especially if you get some of the older ones, which have really good documentation. But some of the Chinese kits, well, I guess they got documentation. It's just in Chinese. So you got to use a lot of common sense, right? So one of the things that you got to take notice of, I always go largest components to smallest. Sometimes that gets you in trouble because you have components that are hidden in between them. That's okay. We can live with that. So you can see how I've got them all laid out. We start at the biggest one, we go to the smallest, just like you do a jigsaw puzzle, all right? You start with the edges, then you work your way into the harder and harder ones. And it also helps you sort components, okay? This is the perfect example for that. I don't have really good documentation. Luckily, these ones here are printed. Sometimes they're not. And if they're not, then we would just use deductive reasoning, right? So I have 3 capacitor spots left. Sometimes it'll just say like C something or whatever. And I only have 3 capacitors left, right? So you can see right here, I got these 2 small ones and I got 1 larger one. And I have 2 spots right here and I've got 1 larger one right there. So sometimes that's what you have to do to figure out what goes where. It's just order of logic, biggest to smallest. Then when you get down to the end, figure it out. It's the best you can do. Okay, and these 2. Oh, these are going to be fun too. These little guys. You know, every time I do one of these live streams, I figure out something that I did and I can do it better next time. This time here, I'll tell you right now, I'm learning that I've got to figure out something to do with my air conditioner. My AC unit is right here above my head and it blows down on me, which is fantastic when you're working, by the way. It's fantastic. The problem is that when I'm recording, my audio is right here. So you guys will get this shh sound, you know? So I have to shut off my air conditioning. And I don't know about you guys, but this is Texas, y'all. It's going to get hotter. So last year I was dying out here recording some videos for you guys. And this year, I just got to figure out how to do it better, you know? Okay, so I have everything in. That's all my components. Yay. There's only one thing I have left to add, and that's going to be my DC wires. But we'll get to that in a minute. All right. So here we go. Let's solder this up. So after you do a few of these, you're probably going to have to stop and start clipping some wires because you can see how they're kind of laying over each other. Yeah, like that. They're impacting now. So I'm going to have to start clipping. So you can see the first step is my iron touches down at the base. If you get a solder blob like this guy right here, just touch it. Suck some of that solder off back to your iron. Look at that, beautiful. Look at this, folks. I've been sitting on this project for probably a year, maybe longer. I used to give out these projects to Biomed 1s and stuff. I'd travel around to the hospitals and I would hand out these projects to the Biomed 1s. You know, I'm a firm believer in learning by doing, and this was like the perfect opportunity, these little DIY kits. So if you're a mentor of biomeds, I highly recommend just go out and challenge your biomeds. Like, hand them one of these and say, hey, why don't you take an hour today and go ahead and assemble this guy and use it as a test to see what they can improve on. In the military, we had regular core competencies that we had to keep up on, and they would test you on certain things to test your core competency levels. And if you had a really good mentor, they would sit there and figure out what you can improve on. And that's one of the things I liked most about the military, is that there was a lot of structure. I'm really not digging these flush cutters at the moment, folks. I'm almost ripping some of these pads off, and today's going to be the last day I use them, put it that way. Come on. All right. So you can see I soldered a whole bunch of them at one time. Gosh darn these stupid flush cutters. I soldered a whole bunch of them, and then you can see now I'm just bending them out of the way. Yeah, these stupid things. A real sharp set of flush cutters, and it's like clip, 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 clip. That's really fast. These guys here just served me for a few too many years. All right. Okay, so I have these two right here, and I got those two to clip, but I'll clip them all in just a moment. Hope y'all can see this pretty good. If not, I can shine a light on the situation. Whew. That's blowing out the camera, isn't it? All right, well, we'll try something else next time. Here we go. So today has been a very busy day, guys. I'm working on some big projects, and man, I'm every single day I'm like, no, don't tell everybody, and then some days I'm like, yeah, maybe I should tell them today, because some of these projects are maybe some game changers for our industry. And I'm working alongside some companies that have up and coming projects, some new products. And betterbiomed.com is still a work in progress. I still meet with my web developer and stuff, and we're still working on it. But every time I work on it, I'm really close to what I want as a product. Then I talk with some company that's already got something that's better than what I'm currently developing. And so we start entering in negotiations like equity, and then, you know, cooperation and stuff like that. Because why would I continue to develop something if somebody already has something that's as good, if not better? And it just happens. It's one of those things. It's so that's one of the things I've been working on, is developing some new websites that are gonna hopefully build my brand to something new, something that's never happened before for this industry. Okay, so the last thing that I've got right over here is my power. You can see it. Got a positive and negative. And if I didn't know any better, these guys here are not the right diameter. Okay, so positive is closest to me. Okay. So square is positive, right? Right. So what I'm going to do, gosh darn it. All right. I'm going to do a little bit of trickery here, folks. This is going to be one of those do as I say, not as I do. So what I'm going to do is I'm going to put some solder on my iron tip, just like this, and come over and touch the point like that. See that? That's why I love live streams, because sometimes it's so difficult to try and tell people how to do this stuff. So I poked the wire through and I was holding it. I laid some solder on my desk. Or you can, that's another good thing for these tweezers, right? They make really good solder holders. And then you touch it with your iron, and then get some solder on the tip of your iron, and then just touch it to the component. But you got to kind of work fast, because the flux will burn off. It burns off of the tip of your iron. Okay. All right. So that is not happening how I'd like. I'm gonna have to strip that wire back a little bit. So you can see what I just did there. I used my soldering iron to melt back a millimeter worth of insulation. Come on. There we go. Much better. Okay, right there. Don't move. Let's do this. And there it is. Okay, check to make sure the positive and negative are not touching each other, because that would not be good. And how about this, guys? I currently have it running, right? Oh no. Check that. Hold on. I think that is for a lithium battery option. I mean, we could test it just the same, but okay. Why didn't learning this has really helped my PTSD? You know something? It's interesting you said that, because not too many veterans are open and talking about that kind of stuff. And humans are designed to be makers, okay? It's what we do. We make things. And I can completely see why fixing things would help with PTSD. I completely see it. Because you're fulfilling your purpose as a human. Okay, so this side over here is the plus, and you can tell that is the wrong size. Right, what are we working with here, folks? Let's try this one. Right. You can see the mess that I have made here across my desk. Oh, look at this, folks. Look at this. So what you guys are going to see is a bunch of flashing lights, but in my view right here, it is not flashing. That's because of frame rates on cameras. It's going to be a difference. So sometimes the frame rates are going to align and sometimes they're not going to align. But what we have is a lit 12 o'clock display. Okay, there we go. We switched the divots. Oh, look. It's also got a countdown timer here. There, you can see it. That was kind of cool. So it's got a whole bunch of different functions, and there we go, folks. I just built that from scratch. I have no idea what that IC is. It is not that complex. I assumed it was just a timer. We got a resistor network. We got a little transistor there. And it's interesting because we do have a battery, 3-volt battery in. I was shoving 5 volts through it. And I'm surprised that this thing is not broke, because I was shoving about 1 amp through it at 5 volts. And there's no way some little battery is going to push a whole amp. But yeah, it's cycling through all the different ones. What? And it has an alarm function. So, there you have it, folks. How cool is that? We just built an alarm clock or a digital timer from scratch. And you guys were right here to see it happen. And it works. What are the odds? Until I drop it. So that's a live stream for you, folks. Everything looks absolutely fantastic. Let's go ahead and let's get you one more close-up look so you guys can see the craftsmanship. So right here, we have our IC, just a couple different caps. And the most important part is to make sure that those diodes right there are opposing and that they're in the correct polarity. I could see how some people would mess that up. It's kind of easy to figure out that transistor right there. The silk screen looks identical. But the other thing, maybe because these are diodes up here, is it's possible that you could maybe put this thing in upside down. And if you do, maybe it won't light up. For me, I used those words right there as my index point to say, hey, that must be the bottom, right? There's no indicator that that's the bottom, but since they're segmented LEDs, you would think that it is polarized, right? So that could be a no-go for some people. And the buttons could also maybe be a no-go for some people. But the buttons were also the hardest part. The legs were bent out of spec, so I had to straighten them up. And then there was some corrosion on the legs, so the solder did not want to bond very well at all. So my last step here, before I take it and I go and actually put this thing into service. Come on, come on. The very last step is we're going to clean it. And this is something important because this is an acid flux. I just created a short today that talked about flux, and that's because I got a whole bunch of different ones. And what you should know is that flux can be corrosive. I mean, they all kind of work the same, some maybe a little better than others. But if you don't clean the flux off, there's many times where it will create corrosion on components or at solder joints. So what we do is we put 99% alcohol on there, we give it a scrub, we clean it up, and then I have a hot air station over there, and we will use that. So folks, there you have it. It's a little timer IC clock assembled from scratch, and we're good to go. So either tomorrow or the next day, I'm going to the coolest electronics store in the world. I did a couple videos from that place called Electronics Parts Outlet. It's here in Houston, Texas, and it is fantastic. Every time I go, they change their inventory. So every time I go, it's something different. And it's just like this giant time suck. And you go in there and you come out like an hour and a half, 2 hours later. And I'm going to do that tomorrow, all right? I believe my first video for Electronics Parts Outlet, I called it the coolest electronics store, something like that. And it's got close to 500,000 views. And that has been phenomenal. And I would love to go back and talk to the owner, because from my knowledge, and I get a lot of comments from people like you guys all around the world, that is one of the last places in the United States that has that kind of look and function, that feel, that nostalgia, where they have toys and they have electronics, demos, all this stuff. So stay tuned. I might be doing a live stream or something from there. Maybe I'll do an edited video. I think a live stream would be kind of cool. You guys tell me what you want to see and I'll walk around and maybe showcase it. That would be kind of cool. But we'll see. Radio Shack was pretty nice, by the way, guys. I do miss Radio Shack. And Radio Shack used to be one of the largest vendors for something called Heathkit. I know a lot of you younger folks, you don't know what Heathkit is. I'm 45 years old, guys. So I do know what Heathkits are, all right? And you can still find them at the coolest electronics store in the world, Electronics Parts Outlet over here in Houston. They still have them. They have them assembled and non-assembled. I have one Heathkit here. I've got one. And it's pretty cool. It's an old electronics lab. And one day I'm going to do a video where I tear it apart and we can go through it. It's got all these tiny little wires that are soldered and whatnot. And they just need to be redone, because you can clearly see that whoever was doing it, whoever put it together, it could be done maybe a little bit better. If you're using an electronics lab, you should probably just make sure the connections are good, you know. Plus, there's a lot of older capacitors and stuff that just need to get changed out. So that's going to be coming up, folks. Thank you for staying on with this recording. It's been phenomenal. I'm glad that worked out. I'm glad it didn't catch fire, especially when I put 5 volts through 3 volts. But If you guys have any other questions or whatnot, let me know. We're going right into the season for trade shows, so I'm going to be on the road a lot. I've got 5, 6, maybe 7 different places that I'm going to be visiting over the next couple months, and I'm very excited because this is when I get to go out and meet a bunch of you guys, and I'm going to be touring some hospitals and stuff. It's just so cool, and I hope to see you guys at those events. Amy Show, MD Expo in Temecula, in just a couple weeks, and then South Carolina. I'm going to be out there in South Carolina pretty soon, and we'll see. I've got a few other requests. Maybe I'll fit in between. Schedule's getting a little tight, but thanks for watching, guys, and stay tuned. I'm going to be posting some other videos over the next day or two, some cool stuff, and I can't wait to tell you guys about my projects that I'm working on. I can't wait, because for me, this is going to be like a career game changer. It may be solidifying my direction for the rest of my career, and for some of you guys, it might be making a career, because I'm giving some of you guys options, which is going to be cool. Anyway, guys, y'all have a fantastic afternoon. All right.